Hello, welcome to this Parallax Quick Byte. We're going to have a look at using the GPS module in your Propeller 2 projects. We'll take a look at the hardware first, as usual. So here we go. I'm using the mini breakout board P2 Edge module, prop plug for programming, barrel jack to USB cable to provide power. RTC, ignore that. We're not using that in this demo, but we are using the GPS module. So here we are, 28504 is the part number. And that just all plugs together like so. Black cable is ground. The black cable can go to any ground pin on the breakout board. Red cable is 3.3 volts, so again just plug that into any 3.3 volt pin on the breakout board. And then the brown cable is our signal cable. In this case it's the output data from the SIM GPS module going into being received by the P2 Edge. So I've connected that to pin 24, and that's all we need to know. So if we have a look at the code, we've got this example that you can download. So just go through, set up your pin settings as per usual. So as you just saw, I've used pin 24 for the receive, so that's good to go. And I'm not using the transmit function, so I just set that to -1 to disable that. The board, we are using 9600 board. That's the default board for the GPS module, so again leave that alone unless you know you've changed it yourself. We're not using any TX functionality here, but if you did want to sort of help with that, please do ask at the forums. And if there's anything specific that would be useful to make into a little quick byte example code, we could also look at that as well in the future. So just reach out on the forums or in the quick byte comments. So for this example, we start by calling the object to our GPS driver, which is here, object GPS. We'll give it the tag name GPS, and that's just the file name 28504 GPS module. And then we can use that object in our code. So GPS start, and we just give it the parameters it needs, the receive pin, the transmit pin. Mode is always 0 for this GPS module, or at least in the way we're using it, and GPS board. So yeah, call the start command and then run the examples. You can just comment in or out the ones you want to have a look at, and then at the end we just call stop. Not entirely essential, but it does free up some resources. For demos it doesn't really matter, but if this was a real application you might want to free up resources. So let's just start with a super simple demo, example 1, and press F10. So there we go, example 1, and it just has read the date and time and the coordinates from the device, and there you go. So let's just have a look at how it works. So bearing in mind we've called start to start the GPS, and then what we do is GPS get new data. So the GPS module is outputting data every 1 second. It's pretty standard that GPS modules, when you buy them, will be set to 1 Hertz data rate, 1 message per second, or one update per second. There'll be many messages within that time. So what we want to do is tell it to get the new data, and we want the RMC message, so we just tell it to get new data, RMC. RMC is one of the GPS messages. You can search for NMEA, and you'll find lots of information on GPS messages. And once we've got the new data, we've got a whole second to use that data before it goes out of date. So within that second we could display it, for example, or you might do other stuff with it, but for this demo we're just going to display it. So yeah, we tell it to get data, and we just tell it what we want. So we want, from the RMC message that we've just downloaded, we want the date, and then we ask it for UTC, which is UTC time, and then lat and lon on the next line. I've asked for that data as well. It's as simple as that. You can handle the data and do stuff with it as you like. For now I'm just displaying it on screen just so you can see how to get hold of the data, and then it's up to you what you do with it there on after. The UTC, just bear in mind that it is UTC time zone, GPS time zone, so if you want to convert that into your local time, then you might want to you just need to add code to do that as whatever you want, or as say, ask for help on the forums if you get stuck with that. But yeah, here's the basics. So just go through the examples. They're all doing different things. Example 3, for example, we'll shuffle through the tools 3 protocols that are pre-stored: RMC, VTG, I think the other one was GGA, and it just grabs it from the module, and then it just stores it as an array and just kind of loops through the array to show you all the different fields that you can access. Example 4 shows you how to wait until the device has valid data. Let's just have a look at our module on the camera. Yeah, so we've got the blue fixed LED lit here, so we know we've got valid data. So I can run, therefore, example 4, because that otherwise would block waiting for valid data. So yeah, here we go. So it's waiting for valid data. Yay, we've got valid data. And it just reads the RMC string and just shows you the contents of it. So yeah, different examples, you can see what's going on. Example 5, the glorious one at the end, brings up lots of windows. And did I press F10? No, probably not. There we go. And that one just shows you how to show debug, not just debug terminal, but also debug windows. And you can see the data on screen there. Don't worry about your speed, because GPS speed is always a bit all over the place when GPS is stationary. All GPS modules are pretty good when they're moving and become more accurate, but when they are stationary, the signal will wobble a few meters left and right. So you will sometimes, it might think it's moving when it's not, and your accuracy of position will not be as good. But as soon as you start moving, it will get much better. And also bearing in mind, I'm in the ground floor of a building, so that obviously doesn't help with GPS accuracy either. So yeah, in a commercial application, the code itself would always filter the data coming from the GPS signal. It would kind of know if you're moving or not, essentially, and then it would, it would kind of filter the data to make it more sensible. Anyway, so the main point is you can see how to access the data coming from your module and how to make use of it. In the driver, which we referenced above, we can just look in there. There's near the top, these are the messages that it currently knows, so you can call for any of these parameters. If you wanted to add some more messages, just add them on here, no problem. These are the protocols. You can, as I say, look them up, NMEA protocols online. You'll find that the RMC string, for example, is structured this way: UTC, status, lat, long, north, south, lon, east, west, knots, etc., etc. So you could add your own other protocols there, and then you could reference them in the same code here. You could just say get new data, GSV, for example, if you add that one, and then you'd say GPS GSV and GPS GSV, I don't know, sat count or whatever you've added. So yeah, you could add other stuff. And towards the end of the driver, there's a few helper functions. There's knots to speed. And you can tell it to return in miles per hour or kilometers per hour. And there's heading to compass. Again, you can give it the degrees heading, and it will return the characters that describe the direction: north, south, southeast, southwest, whatever it happens to be the closest heading. So there's a few little helpers there, and split. You can split out the date. The date will come as 6 digits, so you can split out just the year, just the month. If you look at the examples, they're using these functions, so you'll see how they work. But just so you know they're there, so you can use them in your own sort of code. So hopefully that shows you how easy it is to use the GPS module. You just basically GPS start, and then GPS get new data, and then just read off the parameters you want. And just bear in mind that the GPS data does update every second. So if once your code is more than a second, gone since the last call to get new data, you might want to call that again just to refresh the buffer with the new data. Yeah, you can find the module at the Parallax shop. If you just go to parallax.com and search for the part number 28504, that will bring you up, and as usual below the product you'll find the documents and downloads tab, where there's lots of resources. There's a product guide, you can find schematics, you can find some Propeller C code, you can find some Blockly prop examples. So always worth looking at the product page to get resources, and of course at the Quick Byte page you can find these example codes. downloads. And yeah, ask at the forums or at the Byte page if you have any questions or if you'd like some help. So thank you for watching, and yeah, have fun with GPS in your new project.